Let's talk about a standard normal probability distribution. It's a probability distribution for continuous random variable z that can assume any values such that mean, mode, and median, they're all equal. The mean is 0 and the standard deviation is 1. The graph of the distribution is symmetric and bell-shaped. The total area under the curve is equal to 1. Probability that z is equal to a specific number is equal to 0. And probability that z is between two numbers a and b is the area under the curve on the interval ab. And we use that area to describe the probability. A commonly used notation is n with parentheses 0, 1, where 0 represents the mean and 1 represents the standard deviation. And of course, n is for normal distribution. So how are we going to use TI in order to work with standard normal distribution? Here are all possible cases when we want to find probability that z is between two numbers. Is z is less than one number? Is z is greater than another number? In any ways, these are all the possible cases. For that, we're going to use the TI command normal CDF with the lower value, upper value, 0 for the mean, and 1 for standard deviation. In the case of infinity and negative infinity, we're going to use E99 and negative E99, which is the scientific notation for 10 to the 99 power. In this example, we want to find probability that z falls between negative 1.5 and 1. We're going to draw the normal curve and shade it and clearly label it. So the shaded region represents the probability that z falls between negative 1.5 and 1. Using the chart, probability that z is between negative 1.5 to 1 will be normal CDF with the lower value negative 1.5, the upper value 1, mean 0, and a standard deviation 1. And the answer is 0.775. Now let's find probability that z is greater than 1.5. Again, we're going to draw the normal curve, shade and label accordingly. The mean is 0, standard deviation is 1, and we want to shade the area greater than 1.5 for z. The shaded region is the probability that we are trying to find. In this case, we're going to use normal CDF, 1.5 for the lower value, E99 for the upper value, 0 for the mean, and 1 for standard deviation. For the E, for the scientific notation, we use second followed by comma, and that gives us that E. Now let's find probability that z is less than 1.645. Again, we're going to draw the normal curve, shade and label accordingly. This time we have to shade to the left because we want probability of z less than 1.645. Also, we're going to label the mean and a standard deviation with 0 and 1. Using the normal CDF command, the lower value will be negative E99. The upper value is 1.645 with a mean of 0 and a standard deviation 1, and the answer is 0.950. In this example, we want to find probability that z is less than negative 1.645 or z is greater than 1.96. We're going to draw, shade, and label the normal curve. Now in this problem, instead of finding the probabilities that we want to go ahead and subtract the probability that we don't want from the total probability 1. So the probability that we don't want is for z to be between negative 1.645 and 1.96. So we're going to subtract that probability like we found earlier and subtract that from 1. So the answer for this problem is 0.075. Now, how to find z-score from known area? So we're working with probability distribution for a continuous random variable z that can assume the following criteria. We're going to draw a bell shape. We're going to clearly identify and shade the region that represents the known area. But for using TI, we definitely need to know the left area of Z. Once we clearly find the left area, we're going to use the command on a TI inverse norm. For that, you go to second vars to find inverse norm. With the inverse norm, you need the left area followed by the mean 0 and a standard deviation 1. Let's look at some examples on this. So we want to find z equal to P90. Now P90 separates the bottom 90% from the top 10%. So the left area must be 0.9. And that's the area that we want. Using the inverse norm command, the left area is 0.9, the mean is 0, standard deviation is 1, and the answer is 1.282. In this example, we want to find k such that probability that z is greater than k is equal to 0.85. Now, probability that z is greater than k equal to 0.85 simply implies that the area to the right of k is 0.85, but we need the area to the left of k. So the known area is 0.85, which is the right area, and 1 minus 0.85 is 0.15 is the left area, and that's the needed area. We need that if we want to use inverse norm. So K will be equal to inverse norm, 0.15, the left area, followed by mean 0 and a standard deviation 1. So the answer in this case is negative 1.036. Now, what is Z alpha? It's a notation that describes the z-score with an area alpha to its right, as displayed here. So the area to the right of z alpha is alpha, and the area to the left of it will be 1 minus alpha. Now alpha is a numerical value between 0 and 1. Now let's see how we can use Ti to find z alpha. Since the left area is 1 minus alpha, the inverse norm, the first component will be 1 minus alpha, followed by mean 0 and a standard deviation 1. So this simple step will help us find z alpha. In this case, we want to find z of 0.025. So our alpha here is 0.025. So 1 minus alpha will be 0.975. So we're gonna draw and label our normal curve. We have the left area, that's what we need. We're going to use the inverse norm with the left area 0.975, followed by mean 0 and a standard deviation 1. So the answer here is 1.960. I hope this presentation helped you understand uh, about standard normal probability distribution and other related topics to standard normal probability distribution, such as Z alpha.